general, if we talk about parallel lines, what are we talking about?
Two lines that don't.
Two lines that never cross, right? Okay? So, two or more lines in the same plane. This is important for something we're going to introduce here in just a second. So you really need to say that. That never cross. Now, don't say this out loud. Let everybody have a chance to think. Why does this happen? Or why does it not happen? Everybody got their answer? Okay, yeah, a line's got to be straight. But why will they never cross? This is one of the things where I don't think enough people understand why. What?
Going the same ways.
Okay, they're going the same ways. If these are my two lines, no matter if I have them at an angle, up and down, left and right, why won't they cross? Boom. That's the most important part, and a lot of people don't understand that. Okay? They will never cross because they have the same slope. Everybody understand what we're meaning by slope? Okay? Because, in all honesty, by the end of this chapter, we'll go back and do a lot of slope things from algebra. Okay? Don't say dang, that's fun. Alright? Shown by what? Anybody have an idea what the symbol for parallel lines is? Two little lines is exactly right. Okay, so for us, we could say, again now, how can I name a line? What two ways can I name a line? By the little script letter or any 2 points on that line, right? So for instance, we would say M is parallel to N, right? And then we know that. On a diagram then, so if we were saying that M is parallel to N, how do I show it on my diagram? How do I tell everybody if this is line M and this is line N without saying this? How can I show everybody? And you would turn your book open and you would just know that those two lines are parallel. Any idea? We're learning a lot today. You're going to have a little arrow on there. In years past, they would call this the play button, right? The play button on your phone or whatever. So they have a play button. If there's multiple sets of parallel lines, so then if I go the other way, and I want those also to be, now I'm going to still use my arrows, but I'm going to use two sets of arrows. So in years past, I would say, well, this looks like a fast forward button, right? But I can't just use one arrow again because I already used the one arrow. Okay? Any questions here? So that's kind of the easy part of it. Now, can you draw a cube? Try to draw a cube on your paper. If you don't know how to draw a cube, start by drawing a square in front of you, and then a square behind it like this. And then you're going to start connecting things, right? Something like that. And these should actually be slashes too. Why are they slashes? They're in the back, right? Oh, this one shouldn't be. This one should be. Not this one. Something like that, right? This one shouldn't be. This one. It's in the background, right? that's my cube, okay? So in a cube, what's special about a cube? All of the faces would be what? The same, or squares, right? Okay. Is a square a rectangle or a rectangle a square? Are squares rectangles or rectangles squares? What's more special?
Squares or rectangles?
Squares or rectangles, because a square has specific things that has to be true about it, right? What has to be true about a square? Not only everything that a rectangle is, but they also have all four sides that are the same. Okay? So if you started writing things here, and we started putting letters, let's just go in alphabetical order. I think I got all of them. Okay? So not only can we have parallel lines, but we can have parallel segments. Agree with that? And in a square, we would have two sets of parallel segments. Agreed? They would be opposite of each other on either side. Okay, so if I'm looking at the face that's staring at me in the front, what sets of sides are parallel to each other? BG would be parallel to what? This front one right here. What's opposite or parallel to BG? AF. Okay? And then we could go through, and there's a lot of them though, right? There's a lot of sets of parallel lines or parallel segments. These would be parallel segments. Okay? So, by definition, we said that it was two or more lines or segments in the same plane that never cross that are parallel lines. Well, would you say that BA or AB, I'm going to put a box there and we're going to fill that box in, and GD, would you say that those two segments, if I turn them into lines, so basically extended them, would they ever cross each other? Because they're not what? This one's going up and down, this one's kind of going like this, but it's away from it, right? So if I had a Kleenex box, and I turn this Kleenex box into a cube, right? We're kind of looking at it like this right here. If this is BA and this is GD, if I extended this towards you guys, but then I extended this one up and down, would those two ever cross? They never cross, so are they parallel? No, because they don't have the what? Same slope. Okay? So, does everybody see what I'm talking about though? This side and this side, they'll never cross, but they're not parallel, so they gotta have a name, right? So we would say that in this case right here, these are called skew lines or skew segments. Actually, I'm actually hot in here.
No, it's not. It's fine. It feels good.
I'm gonna turn the fan on. We gotta look at something real quick. I have another vocabulary thing here. This is on the vision tab up here. What chapter again?
Great.
No, maybe not. No big deal. It's too bad. Alright. So again, we would look at a figure, and let's do that now, because what time we leave? 24 or 25? I mean 20 or 25?
24.
So here's my box again, or cube. Okay. And so if we started looking at this, and it says name all segments parallel to a particular one. Sorry if I blocked your view. What would we say for an answer of BC? What segments are parallel to BC? DA, I would agree. The front one, right? What else? FG. The right-hand side? EH, right? Because even though that there's not a plane there, we can always make a plane by slicing it down the middle, right? Okay, so if we go back to BC, what's a segment that is skew to BC? DE, EF, those are both B. So in a sense, when you're asked to find the skew things, you're looking for things that are going kind of in the opposite direction, right? BC was going up and down. Now we're looking at side to side. That makes sense? And again, we'll talk more about this later, but all the letters would be called points or vertices of that cube. Agree with that? I think they tell us all this. So then they want to skew. All right. Then we go back to planes. So again, what's a plane? How can I name a plane? Any 3 points on that plane, right? So if they look at, name the plane parallel to plane ABG, a plane in a cube is basically a side or a face. So when they say ABG, how could you describe that to somebody that just walked in the door? It's the bottom one, right? It's what it's sitting on. So what is parallel, what plane is parallel to the bottom? The top, right? Any combination of D, E, C, and F, with 3 of those common, or letters in common. Okay? That makes sense? All right. What time did you say we leave? Oh, yeah, lots of time. So let's introduce this word. This is the really, really important word for today. So vocabulary-wise, I lost my wheel again. So the next introduction is the word transversal. So go ahead and draw a set of parallel lines. And again, for whatever reason, whenever I draw parallel lines, mine always go left and right, but you can draw however you want. Let's call them M and N again. And again, how do I know for certain that they are? Right now, they're not necessarily parallel. Even if I meant them to be, the only time that they would become definitely parallel is me putting that arrow on there. Okay? So a transversal then is this line K, or R. I guess I made it an R. Okay? And so, there's my transversal. A line that intersects or crosses 2 or more parallel lines. Now, would you agree that I could draw this line R going up and down through lines that weren't parallel? So if I drew M like this, and even though that they're not going to connect, I could say this is N and this is M, and I could still have a line that goes through both of them. So a transversal can go through either set of lines. The one on the left is going to have some specific things that are really important to it. Okay? And that's where we're going to kind of start looking at. But in either case, we're going to talk about the sets of angles. If you would look at where my transversal, again, if I call this R, Do you recognize that when that transversal went over that line, that these angles were made? Everybody see those angles? Okay, and if I come back over here, I can put them in the same order. Okay. So this is the important part of transversals, is that you recognize and see those angles that were formed. And they're going to have sets of angles or angle pairs that were formed because of that. Okay, so we are going to first talk about real general groups, and the first general group are called exterior angles. When I talk about exterior angles and transversals, I'm going to go with, do you see where the parallel lines or just your regular lines would have like angles that are inside or in between the lines and then angles that are outside the lines? Would that make sense to everybody? So exterior means what? Outside, right? So we want to name the exterior angles of either group. What would you say? What are the exterior angles? Angle 1, angle 2, angle 7, and 8. Everybody agree? Okay. Let's stop right there. Try to get these two running. Oh my God.
You need these tests back.
Red record? Should you doing that? Oh, don't do it for you. They got it, it's like 11 to 11.
No, I wasn't, I had to work.
Have a good rest of the day. Cora and Nurse, you can test one, hopefully, after, then you can stop by. Get a great one.
You'll see when you get there.
Have a good rest of the day. We were taping all that.